Today's daily code problem of the day is reschedule meetings for maximum free time part 2, number 3440. For this problem, it's similar to yesterday, so we get an integer event time and two integer arrays start time and end time, each of length n, and these represent the start and end times of n non-overlapping meetings. The only difference is this time we can reschedule a meeting to be after or before another. So for example, example 3 is a good one to look at. If we take this meeting that goes from 3 to 4, we could put it from 8 to 9, clearing up from 1 to 7, giving us a 6 length output. So let's go ahead and jump into this problem. First thing we are going to do is set up our variables, our base set of variables, which will have an integer n, which is equal to our start time.length. We're initializing that because it was initialized over here. And then we're also going to have a Boolean array. This Boolean array is going to basically keep track of whether a meeting I can be fully moved into an existing free gap, either to the left or right. So this is going to flag and track meetings if they can be moved into an existing gap. We'll have our Boolean array, and we'll call this movable, or just M for short. And that is a new Boolean array of length n, because we have an n amount of spots. Next thing we're going to do is we're going to do a two-directional pass. We're going to first pass forward, and then we're going to pass backwards. So the loop is going to compute the max free gaps in both the forward and backward direction. So for each integer I is equal to 0, as long as our t1 value is equal, or sorry, we're going to have I is equal to 0, t1 is equal to 0, and our t2 are equal to 0. And as long as our I is less than n, I can increment. So this loop computes max free gaps in two directions, forwards and backwards, or to the right and to the left. So in our forward pass, we're going to basically check, can the meeting at the position I move left first? So if the end time of I minus the start time of I less than or equal to t1. So we're basically going to check if the duration of the ith meeting is less than or equal to t1. T1 is going to be the largest gap before this meeting so far. So initially it's 0 because we have 0 gaps behind us at 0. But as we move forward, we will compute the max gap, and T1 is our max gap to the left. So if this is true, we'll mark M of I, or a meeting gap of I, is true because this meeting can move left. We'll then update our T1 value. So T1 will be equal to math.max of T1, or start time of I, minus is I equal to 0? If so, it'll be equal to 0. Otherwise, it'll be equal to end time of I minus 1. Basically, what we're checking here is we're going to update our T1, or our largest gap to the left, to be the max gap before this meeting. So if there's no gap before this meeting, it will be 0. If there is a gap before this meeting, we'll compute what the last end time was, and it'll be the start time minus the last end time, or the gap between the two meetings. Next, we're going to do a backwards pass. So that was our front pass. This is our backwards pass. So can the meeting of n minus I minus 1 move right? So the lastmost meeting minus our I value, so whatever meeting we're currently on, can it move right? So if we're at, let's say, meeting 2 on example 3, can this one move right? It can move right here. So that would be the n minus I minus 1. So I is 1 in this case. This is the first meeting after the 0 index meeting. So if the end time of n minus 1 minus I minus 1 minus the start time of n minus 1, or the current last value, minus the minus the start time of n minus 1, I minus 1. If that is less than or equal to T2, or the current largest gap to the right, then our meeting gap will be n minus I minus 1 equal to true. So there's this the meeting at this index can move to the right somewhere, leaving a gap in this spot. Then we'll upgrade or update our T2 to be the math.max of either T2 or the is I equal to 0. If so, it'll be event time. Otherwise, it will be start time. Otherwise, it will be start time of n minus I minus end time of n minus I minus 1. So T2 max gap after meetings n minus I minus 1, or the event time minus our current value minus 1 because it's 0 indexed. And that's how we're going to check for gaps in the forward direction. So at this point, if our m of I, or the meeting gap of I, is true, then that meeting can be moved completely to an adjacent free gap. Now we're going to try and move or not move each meeting. So we can have an integer by this loop. So outside this loop, we're going to have an integer called our result. So int result is going to be equal to 0 initially. And for each integer I is equal to 0, as long as I is less than n, I can increment. And we're going to go over each meeting and ask what's the biggest free time we can create around this meeting if we move it or not. And we can check simply, can this meeting be moved? If it can, we'll subtract the end time of the next meeting and the start time of the previous meeting, if there is one. So our int left, meaning we'll move it left, is equal to is I equal to 0. If so, we leave it as 0 because it is the leftmost meeting. There's nothing before it. Otherwise, it will be end time of I minus 1. And then we have our right value. So int right is equal to is I equal to n minus 1 because it's 0 indexed. If that's true, then it will just be event time because that's the last it could be. Otherwise, it will be start time of I plus 1, or the next start time. So those are the two possible free regions that we can make if this value can be moved. So we have two options. Option 1 is we can move the meeting into the space, or option 2, it can't be moved and it's stuck. So we'll first check if our meeting of I is true, because we have a Boolean array, then the result will be equal to math.max of either the previous result or right minus left. We already computed the two gaps from this meeting. Option 2 is the meeting can't move. So we'll have else our result equal to math.max of either result or right minus left minus end time of I minus start time of I. And that's simply because we already computed the end time of the next one and the start time of the previous one. And we want to subtract the actual meeting length because it can't be moved. We've determined that it cannot be moved, so we have to add that back. And then we can simply return the result. So if we run this, passes our test cases, and if we submit it, passes all solutions. So thank you, and follow for more daily code solutions.